let's start our session. Before that, very good evening. Akanksh, shall I start the session? Yeah, I'll start the session. Yeah. Can you tell me in the last class what we completed? In the last class, actually we are discussing the graphs. Am I right? In the graph, we already completed the graph distance versus time and speed versus time. Am I right? Yeah. Now, Amma? Yeah, distance versus time completed, right? Speed versus time. How many graphs I explained? 4 graphs. So one is a line passing through the time axis. One more is parallel to the time axis. One more is straight line, isn't it? So based on that, I'll give one question. Can I give one question? So the question is, I'll give you a situation. For that situation, you must draw a graph. Okay now? So now, yeah, the situation is, this is the object. This is the object moving in a straight line path. If the object moving with 2 meters per second. The object is moving with 2 meters per second in a straight line motion. For time is equal to 6 seconds. Time is equal to how many seconds? 6 seconds. The object is moving 2 meters per second in a straight line. How much time? 6 seconds is travel. Now I want the speed versus time graph. I want the speed versus time graph. So you can take time on x-axis, the speed on y-axis. Now how do you represent here? Tell me how you will have the graph here. You will have the graph. Look at here. It is initially starting from what speed? Initially it's starting from 2 meters per second. Right? You can take here. This is 1 second. This is 2 seconds. This is 3 seconds. This is 4. Likewise, 5. This is 6. Likewise, you can take time on x-axis, and this is you can take 1 meter per second, 2 meters per second. This is you can take 3 meters per second. Now here, how much time it is traveled with 2 meters per second here? 6 seconds. So which means 1 second it is have 2 meters per second. 0 time also it has 2 meters per second. Even 0 time it has 2 meters per second. At 1 second also it has 2 meters per second. At 2 seconds also it has 2 meters per second. 3 also 2 meters per second. 4 and 5 and 6. At all instants it has how much speed? 2 meters per second. So if I take this graph here this way, if you join all these points, what you will get here? This is the way you will get a straight line. So this straight line represents for velocity and time graph how this straight line will be parallel to the time axis. Understand? This line is parallel to the what? Time axis. Any line parallel to the time axis represent the object moving with constant speed, constant velocity. Understand? Now, if this is a graph, now my question is, what is the distance traveled by the body? What is the distance traveled by the body? Here the thing is, the distance traveled by the body, you can you can get by using the slope of the graph. Slope of the graph or area of the graph? Which one is telling that? In the speed versus distance, the slope represents what? The area represents what? In the speed versus time, the slope of the graph represents acceleration. And the next thing is, in the speed versus time, yeah, the area under the graph represents distance. See here, what is the area under the graph here? Which one is the area under the graph? This portion, this complete portion is the area under the graph. So now this area under the graph represents the distance. Now how do you find this shape is look like what? This area look like what? Rectangular. When it's a rectangular, for this rectangular this is length and this is represents breadth. So tell me what is the length here? Area of the area here. Area is equal to area you can take as A1 is equal to, tell me, length into breadth. Length represents the 6 seconds, breadth represents that 2, so totally distance traveled area represents what? 12. So that is 12, the distance is 12 meters is our answer. This is the way we can find the answers. Understand? Yeah, no. Can I go for the next question? Yeah, I'll give one more type of problem, one more example problem. So I will give the graph. So this is the way the graph we have. This is 10 meters per second, and this is a force. This you can take 2 seconds time. From the 2 seconds, this is the way we have. This is 2, this is 4, this is 6, this you can take 8 seconds. This is the way we have the graph. And the name I will give, this is 0, this point is A, and this point is B. Understand? So this is the way the graph having. In that first question is, what is the OA line represents what kind of motion? OA graph. OA line represents what kind of motion? What kind of motion? This is the first question. Tell me, what is the OA line represents? OA graph is represent what kind of motion? OA graph represents what? Yeah, very good. Yeah. This is speed versus time graph. The speed versus time graph. When this is a speed versus time graph, the OA graph represents what? Yeah, accelerated accelerated motion. Very good. The answer is what? It represents accelerated motion. It is represent accelerated motion. Say, when it is representing the accelerated motion, what is the acceleration of the body? Second question is what? What is the acceleration of the body? How much is the value of acceleration? Find out. How to find acceleration in a speed versus time graph? Who will represent the acceleration?
Slope of the graph.
Very good. Here from up to where it is traveled with accelerated motion. In how many seconds it traveled with accelerated motion?
2 seconds.
Very good. When it is 2 seconds, what is the acceleration of the body in 2 seconds? The slope. How do you know it? How do you know it? How do you find the slope here? Slope is nothing but anywhere slope is equal to y2 minus y1 by x2 minus x1 is a slope mathematically. Here you can take, this is a origin 0 comma 0, that you can take x1 y1. This point you can take second point, that is x2 comma y2, that is 10, 2 comma 10 is a origin, coordinates of this point. What is this coordinate? This 2 is representing the time, this 10 is representing the speed. So that is y2. Now here, if I apply this same thing, y2 minus y1. Here y2 is 10, minus y1 is here, this is 0, by x2. What is x2 here? x2 you can take 2, y2 you can take, y1 you can take 0. Finally, 10 by 2, 2 ones are 2, 5s are. So here the answer is 5 meter per second square is the acceleration it is having. Understand?
Yes, sir.
Similar way. So here with this 2 seconds is traveled with what acceleration? With this acceleration it traveled. Now other question here, in this only other question. The other question is, what is the graph AB represents? AB graph represents what? AB graph represents what? Tell me, what is a graph AB? Graph AB is nothing but from this point to this point. What it is represents?
The body is moving with constant speed.
Very good. So that represents answer is what? It is moving with constant speed. But what is the value of the speed? What is the value of the speed? Tell me, what is the value of the speed? How much speed is? How much?
Meter per second.
Very good. 10 meter per second. Now same way, what is okay? Is this totally completed? Now here, what is the distance traveled in 2 seconds? What is the distance traveled in 2 seconds? How do you find distance traveled in 2 seconds? Do it distance traveled in 2 seconds. The question is what?
20 meters.
Distance traveled in 2 seconds. How do you know 20? Who will represent generally distance traveled? Distance? Yeah, you have to take area under the graph. What is the area under the graph here? Where is the area? So this total part is what? Area under the graph up to here. Understand? This total part is the area under the graph. This represents as a how? A triangle. Triangle. What is a triangle area? What is the triangle area? triangle. It represents triangle. Tell me. Triangle area. Triangle area half into length into height, kada? Breadth into height. Half into breadth into height. Here in this graph, this represents breadth, this represents height. Am I right? So the breadth value is 2, the height value is 10. Since the answer is what? Half into breadth value is 2, height value is 10. 2 gets cancelled, which is equal to 10 meters. This is A1 area. And similar way, one more question. Distance traveled in total 8 seconds. Distance traveled total 8 seconds. Distance traveled in total 8 seconds. Distance traveled total in 8 seconds. So, yeah.
If you want to consider the area, we should have to consider the other triangle also.
What other triangle?
OAB.
OA. Yeah, to find the total distance, you should consider total area. Total area means this is also you need to consider. This part of the area also need to consider. Understand?
Not only it's like 2 seconds only, we are considering only one triangle also. The triangle is similar to the
Actually, who will give the distance travel here? The area under the graph, not out of the graph. Area under the graph. This is a graph. Under area become what? This one. Understand? It is not under the area. Okay? Yeah. Now I am asking the question what is the distance traveled in total complete 8 seconds? When I am talking about complete 8 seconds, so you should consider total area under the graph. So what is the total area under the graph here? So this total part. Will consider as the area under the graph up to here. To find out, you can divide the 2 parts here. This total area. This is one is triangle area. One more is what? Rectangular area. Already we done the triangular area, so you should do the rectangular area. So what is the rectangular? So the rectangular area is what? From here to here. Here to here you can consider as a length. Length you can take it as a 8 minus 2 as a 6, and this is representing the breadth is you can take 10. So if I use that area you can consider as A2. A2 is nothing but length into breadth. Length value is 6, breadth value is 10, total is 60. So this is happened only half part. But I'm asking total length, since you can add total, to find the total length, you can add area 1 plus area 2. This is equal to total length, which is equal to 10 plus 60, which is equal to 70 meters. Distance is traveled in this direction. Understand?
Yes.
Yeah. So this is all about speed versus time graph. Next, let's go for other graph, that is acceleration versus time. Shall I take acceleration versus time?
Yes, sir.
I have one more question. Can I ask? Yeah. So the one more question is, note down the one more question. This is speed versus time graph. This is speed versus time graph. So this is the way they given the graph. when this is the way they given the graph, so here among the, I'll give some options to you. So the options are, first option is, this is a graph, this is distance versus time graph. And second option is distance versus time graph only, distance versus time graph. This is the distance versus time graph. And third option is, this is the way we have. Fourth option is we have the one more graph like this is the way we have. This is distance versus time. This is the distance versus time. Now, actually, this is speed versus time. For this speed versus time, which of the following graph is suitable? Which of the following graph is suitable? So this is the speed versus time. The same graph, how do you representation with? How? Why? How?
Because it is moving with uniform motion.
Which one is moving with uniform motion?
The graph you mentioned previously.
Yeah, this is a graph mentioned with what? Mentioned with uniform motion. The object, this graph is represented object moving with constant speed. When the object represents constant speed, so same situation, how do you represent with this distance versus time? So which, how this is the second one, how it is second one? Explain me.
If we draw the slopes, we can.
Yeah, here this is passing straight line through the origin. Okay, in the distance versus time graph, a line passing through the origin and it has some slope that represent the constant speed. So this graph find the same representation of in terms of distance and time. Understand? So this is correct. Very good. You are very good. Exactly, you have understand what it is. Okay. So let's go for the other graphs. The other graphs are write down acceleration versus time. So other graph is what? Acceleration. The other graph is what? Acceleration versus time. Tell me, what is this first graph? First one is, in that acceleration versus time, you will take time is on x-axis, acceleration is on y-axis. Okay? Now the first graph is line passing through what? Line passing through time axis. First graph name is what? Line passing through time axis. Line passing through time axis represents what? What it is represents? Line passing through time axis, what it is represents?
The body is at rest.
See, this is a time gather. This is a acceleration. There is no acceleration for body. No acceleration for object. That's it. This is the thing we can get from this graph. This is the first graph. Let's talk about another graph. Okay, so this is the time, and this is the acceleration, and you have a graph like this way. This is the way we have the graph. Now this represents what? What it is represents? What it is represents in this graph? What it is?
Constant acceleration.
Very good. Object moving with what? Constant acceleration. So you can write object moving with constant acceleration. Body moving with constant acceleration. When the body is moving with constant acceleration, same graph I want in terms of speed versus time.
Constant acceleration.
Same graph I want speed versus time. Same representation. How do you represent speed versus time? How the graph will be in speed versus time. This is acceleration versus time. The same representation I want with speed versus time. Which one show it? Which graph it shows?
Quantum original goes in straight lines.
Yeah, it is. This is the graph. Understand? This graph shows that it has constant acceleration. Generally, in the speed versus time, who will give that acceleration? Who will give that acceleration generally in speed versus time? The slope of the graph represent the acceleration. So the slope is constant since this shows the constant acceleration. The same representation with acceleration versus time shows a line parallel to the time axis. A line parallel to the time axis in the acceleration versus time, and a line passing through the origin having some slope in speed versus time will be the same representation. Understand?
Yes.
Next graph. One more. This is acceleration, and this is time. This is the way we have the graph.
Acceleration suddenly increases at the instant point.
How much sudden? How much it is increased? How much value it is in? Huh?
Infinite.
Infinite. Is it possible practically?
Sir?
In the instant time, the object is accelerated or changed its acceleration to up to infinity value. Is it possible practically? No, not possible. Since the graph is also not possible. This graph is not possible practically. So how do you say why it is not reason? Tell me reason. Why it is not possible?
Because having infinite acceleration in your instant time is
Reason also right. Why it is not possible? Reason also right. Next graph. Can I say next graph? Yeah, next graph. This is our one. Next graph is what is this graph? What is this graph? What is this graph represent to you? What information it is giving? What information it is giving? Tell me. So the representation is object moving with equal change in acceleration. Object moving, equal change in acceleration in equal intervals of time. In equal interval of time. Here it is not, speed is not changing. Acceleration itself it is changing with equal change in acceleration in equal intervals of time. Okay. So this is about what? This is about what? This is about what? Moving. Next, can I go for the next graph? So the next graph is, this is acceleration, this is time. This is the graph. What it is represents? What it is representing? The object is changing the acceleration unequally with the time. Unequally with what? With the time. So this is the graphs. Understand? So here till now what graphs we discussed? What graph we discussed? First one is distance versus time. Next graph is speed versus time. Next graph is what? Acceleration versus time. Okay. Now observe this acceleration versus time. This is acceleration versus time. In this acceleration versus time, you have to observe two things again. So one is slope of this graph. One more is area under the acceleration. So what is the slope of this graph represents? Slope of the graph represents no physical quantity, only the area. What is that? Area under the graph represents the speed. Understand? The area under the graph. Better write down. The area under the graph represents what? Speed of the body. Speed of the object. Okay. Only the area will give some information. That information is what? Distance travel or speed of the body. Okay. Now coming to here. So in distance versus time, speed versus time, acceleration versus time. Tell me in this distance versus time, the slope represents what? Slope represents what? In distance versus time. Slope will give speed. Very good. Speed. Slope will give speed. What about the area? Is the area will give any information to you in distance versus time? No information through area. Same way, in speed versus time, the slope will give what? Slope will give. In the speed versus time, slope will give speed. Very good. Not speed. Wrong. It will not give speed. It will give acceleration. Acceleration. What about area? What is area will give?
Distance covered by the wall.
Okay, distance. Same way, in acceleration versus time, the slope will give nothing. Slope will not give anything. But the area under the graph is speed of the object. So this is the way. These are the very important things you need to remember every time. Understand? So here, in distance versus time graph, the slope will give speed. In speed versus time graph, slope will give acceleration, area will give distance. And the acceleration versus time graph, the area under the curve, area under the graph represents the speed of the object. So this is a useful information to when you are trying the graphs, when you are having the graphs. Okay, na? Yeah. For today, I'll stop the thing as we have done with 10. Since I'll stop the session. In the next class, we'll continue. I'll give some examples and also we'll go further. Next concept, and also I'll discuss some few problems related to your material. Understand? In the coming class. Today I'll stop the session. Bye.
Thank you, Subhash.